Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 68 in chapter 7. In this chapter, we talk about work and energy. And normally, when we consider the kinetic energy of a spring, we don't consider the mass of the spring, but the thing changed. In this situation, we will consider the kinetic energy, both the mass of the spring. See how it happens. See, there is the object connected with the spring. It does the oscillation motions. And there, we need to consider the kinetic energy for this system. It can include two parts. First one is the kinetic energy for this mass. It's very easy, 1/2 mv0 squared. And this velocity is given, right? It's given because you can see it tells us one end of spring is fixed and the mass m is allowed to just do oscillation horizontal. No friction is considered, and each point on the spring moves at velocity proportional to a distance to that point. So that means if we just cut this spring at small fractions, so the length for this spring is dx, and the velocity for this fraction of the spring is vx. This Vx just equal to x divided by d times V0. There, this V0 is the mass on the end moves with speed V0. So the mass of the velocity of the mass is V0. So the cut fraction dx, the velocity is this one. Agree? This problem tells us is proportional to the distance from that point to the fixed end. So this is x divided by the d, the total length, and then times v0. This one. Agree? And then how much mass for this small fraction? Because we cut it in this small fraction, and the mass is uniformly distributed. So the density for the mass is the mass divided by the total length d, and then this length for this small fraction is dx. So the mass for this small fraction is dm. Agree? Do you agree this one? Do you agree this one? Then it's very easy. So now we need to find the kinetic energy for this spring. It is still 1/2 m times the velocity v squared, right? And the v squared, the v is given, is vx squared. The mass for this small fraction is dm, do you agree? And 1/2. And this is the kinetic energy for this small fraction. And then we need to do the integral for the whole spring. And this mass just changes with the dx. So we input this equation inside. Now, this equation looks like this one, agree? And then we do the integral for the dx from the 0 to the d. Agree? This is the kinetic energy for the spring. Now we add the kinetic energy from the mass and the kinetic energy for the spring. This is the total kinetic energy. And we do the calculation there. And then you can do the integral very easily by yourself. You can find the final answer is this one. Then we proved it. Thank you.